What is an ESP? The unsung hero of power plants. Imagine a massive power plant, its chimneys belching out smoke into the sky. For a long time, that smoke was filled with harmful pollutants, tiny particles of ash and dust known as fly ash. These particles, if left unchecked, would contribute to severe air pollution, respiratory illnesses, and environmental damage. The heroes that stepped up to solve this problem weren't a team of superheroes or a new kind of filter, but a clever piece of technology known as the Electrostatic Precipitator, or ESP. At its core, an ESP is an air pollution control device that uses static electricity to remove fine particles from a flowing gas stream, like the exhaust from a coal-fired power plant. It's a surprisingly simple concept with a powerful impact. Inside the ESP, there are large metal plates and wires. As the dirty gas flows through, these wires create a strong electrical field, giving all the tiny fly ash particles a negative electrical charge. Think of it like a static shock, but on a microscopic level. Once these particles are negatively charged, they are drawn to the positively charged metal plates inside the ESP. Similar to how a magnet attracts metal, the particles stick to the plates, effectively precipitating out of the gas stream, leaving the air cleaner. Over time, these plates are cleaned, often by a mechanical hammer or wrapper, which causes the collected dust to fall into hoppers below, where it can be collected and disposed of safely. This process prevents millions of tons of pollutants from entering our atmosphere each year, making ESPs a critical component in the ongoing effort to make energy production cleaner and more sustainable. They are a silent and visible guardian, ensuring that the power we use every day doesn't come at the expense of the air we breathe. The widespread adoption of ESP technology has been a game changer for environmental health, particularly in regions that rely on fossil fuels for electricity generation. Before ESPs became a standard part of power plant infrastructure, the plumes of smoke from chimneys were a visible sign of a serious pollution problem. Cities near power plants often suffered from poor air quality, and the fly ash would settle on homes, farms, and waterways. The introduction of ESPs, along with other pollution control technologies like flue gas desulfurization, has drastically reduced particulate emissions. This has led to cleaner skies, a lower incidence of respiratory illnesses in local communities, and a significant decrease in environmental damage. While the technology itself may seem complex, its impact is easy to understand: cleaner air. The success of ESPs highlights how a smart, engineering-based solution can have a massive positive effect on public health and the environment. They represent a key part of the bridge between older, less clean energy sources and the renewable energy future we're moving towards.